Hi, this is Tom, and in this video we're going to take a look at a work problem. So, let me read this. It says, Mr. McGregor's grandson can destroy his garden in 5 hours. If the neighborhood dog gets into the garden, oops, it should be the dog destroys it in 4 hours. How long to total garden destruction if the boy and the dog work together? Well, let's take a look at this problem here. So, if I'm going to set up a table, and you don't have to go through every problem this way, but it helps you to understand the intuition behind work problems. There's a funny subtlety. So, let's say I have the boy by himself. So we'll start with the boy. Okay. And we're going to start here with, I'm going to erase that, fix that. Let's start with time. And boy. Now, if the boy works for 1 hour, he's destroyed, boy, he's destroyed 1/5 of the garden. Now, if the boy works for 2 hours, then notice he destroys 2/5 of the garden. So 2 times 1/5. If the boy works for 3 hours, then he's accomplished, oops, that's a 1 up there. Then he's destroyed 3/5 of the garden. And if he works for 4 hours, oops, then he's destroyed 4 times 1/5, because each hour he gets a fifth of it done, and then another fifth, then another fifth. So after 4 hours, he's destroyed 4/5 of the garden. In 5 hours of work, well, how much has he destroyed? The entire garden. And so we get 5/5, but 5/5 is also 1. So notice that when we get 1, 1 represents the completed job. The job is finished. Now, let's take a look at the dog. Now, here's where it gets more interesting. If the dog works by himself or by itself, in 1 hour it's destroyed 1/3 of the garden. If the dog works for 2 hours, the dog is, and I could have written 1 times 1/3, and for the boy, 1 times 1/5. Now, if the dog works for 2 hours, then he's destroyed, whoops, he's destroyed 2 times 1/3, or he's destroyed 2/3 of the garden. If the dog works for 3 hours, each hour another third is gone. He's destroyed 3/3, and so the dog working by itself takes 3 hours. Now, let's put the dog and the boy together and see what they've done. Now, if they're working together, we'll add their efforts, and let's see, we'll call this accomplished now. Well, what have they accomplished? They've accomplished 1/5 times 1/5 plus 1 times 1/3. These are really in 15ths, and I'm going to do this a little quickly here, but this is really 1/5 is the same as 3/15. So let's change that into everything into 15ths for a common denominator. And thirds, that's going to be 5/15. So working together, they've destroyed 3 plus 5, 10/15 of the garden. So let's say that the two work another hour on this. Well, that's going to be 2 times, and the 1/5, I'm going to write it as 3/15, plus the dog's also working 5/15. So this is really 6 plus 10/15. So in 1 hour, they've destroyed the entire garden and could even be destroying part of it again. So what we really know is this is past done. So what we think is working together, it's going to take somewhere between 1 and 2 hours. Somewhere in here is when the two working together get the job done. And the question is how much time does it take? So we'll call time, I'm going to give it a t. Now let's take a look at this problem. Notice that the time is multiplied, since they're working together, by both of them, by the rate at which they work. So the boy has we'll call it boy's rate is 1/5. And the dog's rate is 1/3. So if I replace the actual time, for example, if I replace like the 2 with a t for time, we can solve this problem. And so that's what we're going to write. So the time is what we don't know, but we know the boy's rate, that's 1/5, plus time. We know the dog's rate, every hour, dog gets 1/3 of the job done. And we know that the job is done when it equals 1. So the question is, what is t? And this is a simple rational equation. And we're going to solve it the same way we have we're going to clear fractions. And we've already discovered the lowest common denominator is 1/5 is 15. So clear fractions by multiplying all terms by the lowest common denominator of 15. All right, so let's do that now. So I'm going to write this here as t 1/5. I'm going to leave some space because I'm going to put a 15 in there. T 1/3 equals 1. Let's go grab another color for the lowest common denominator. So I'm going to multiply every term by that 15. And scroll up. So notice here, the 5 and the 15, they share a common factor of 5 that cancels, and so really the first one becomes 3t. Plus, the 3 and the 15 in this next one share a common factor of 3, so those would reduce, and we're left with 5t equals 1 times 15, which is 15. We add our like terms. This is 8t equals 15. Divide both sides by 8. T equals 15/8, which is almost 2 hours. They can do the entire job. So almost 2 hours. And that is how you solve a work problem. Now, there's a couple different things you could, so it always works out as the time times 1 over, we call it, you'll see the formula is R1 for the rate 1. In this case, rate 1 was the boy, plus t times 1 over R2, or another rate, the person working alongside. In this case, it was the dog, equals 1. And sometimes some people will even factor the t's out. I find that to be a little less successful, but you can do that. And you can also think of it as 1 times 1 over R1 plus 1 over R2 equals 1. So any of those formulas work, and the best way to get used to them is just to practice doing it. Oh, and there's one more way you can do this, is you can also multiply the, if we look back at this first equation, you could also write this as the time over rate 1 plus the time over rate 2 equals 1. And that is how you solve a work problem. Thanks for watching.